chapter 4 review on functions.
Yeah.
The first big thing I see come up on almost every Regents exam is inverse variation, and this is going to be a formula we want to memorize for your Regents. Inverse variation, you guys could see the words, especially in a problem, they might say like inversely proportional. Inversely proportional or like inversely related. All those words like mean inverse variation. And inverse variation is y equals k over x. And this formula is like a general formula. It means y varies inversely as x. So take a second, go ahead and read through our first example. There's some keys in here. We want to figure out like which part represents the y, which part represents the x in here. Right, you guys see the word varies inversely right in here? Alright, so that's going to be our big clue that we have to use inverse variation. And we want to identify, you know what x's and y's are talking about the length of a violin string varies inversely as the frequency. So we want to create our own formula using this stuff. So what do you guys think is like the y? What could we represent that as? It's not y varies inversely as x, it's the length of the violin string varies inversely. Yeah, is it the length of it? Yeah, it's 2L. Good. So L equals K over, well, the next part is as the frequency of the vibration. So, yeah, we do VF, frequency, whatever. Just something to represent that second part. So we have the length varies inversely as the frequency. Now, once you guys have your little formula that you're going to use, right, we're going to do some substitution. A violin string, 14 inches long, vibrates at a frequency of 450 cycles per second. So what do you guys want to put in place for the L? 14. Great. Okay. Equals K over 450. Perfect. All right. You got to find K. How do we do that? Good. And then perfect. So we've got that. Good. Cross all sides. 14 times 450. So 6,300? Is that right? Okay? Now once you guys have K equals 6,300. K is called your constant of proportionality. So what we're going to use is this K again though to answer the second part. So this time it says find the frequency of a 12-inch violin string. Right? Well, what would the L be? Do you guys know? 12, good. And then K is going to stay K. And then we want to find the frequency. We don't know what F is. Okay. Now we're going to do our cross multiplying again. Anybody need calculators or somewhere in the answer? 525. The frequency to be 525. How is your math in that part? Okay, one thing when you guys are dealing with inverse variation, when one value increases, the other one has to decrease. So at least you could kind of check to make sure things make sense. If you were going from a violin string that was 14 inches to 12 inches, that's going down. So the other part has to go up. So you went from 450 to 525, so that part is increasing. That's why it's inverse, because one value goes down, one goes up. Right? A graph of inverse variation looks like this, where as you're increasing on the x-axis, what are your values doing on the y? Decreasing. Good. Right, so inverse graphs look like this. Again, one value goes up, the other goes down. Right. I bet you'll see one of those. They really like inverse variation in there. Do you guys remember doing that stuff?
Yeah.
With that? Domain and range is also a really big thing. Make sure that we know that the domain is your x. So when you're looking at, like, on the x-axis, you want to look the farthest value to the left, the farthest value to the right. So when we look at our little drawing here on the x-axis, when we look on this part, what's the farthest value that you have on the left? Might be easier to count on your right. Okay, -5. Did everyone else get -5? Okay, good. That's the farthest value to the left. Now, what's the farthest value to the right?
8.
That's 8. Anybody else get 8? Good. Right. Now, when we go through to write this, you got to be really careful. Does anybody know how we can actually write what the domain is? How we want to organize it? Yeah, good. X is in the middle. Are we including these values or are they closed? Yep. So we need that equal to part. We want -5 to 8. Okay. The other way, Leslie, that you guys could see this is using brackets. And you could do -5, 8 like this in a bracket. Okay, because the bracket also means including.
But if it's open or something, it's
parentheses. Exactly. Yep. I don't usually see like this, but this is an acceptable answer. They usually won't put those as multiple choice, but if someone did write it like that, it's okay. Okay. So your range is going to be the y. We're going to look lowest to highest. So on the y-axis this time, so we're looking at numbers here. You want to find the smallest number to the highest it goes. Thanks. Andrew's saying -3. What's the tallest it goes? 2. Good job. Yep. Tallest is 2. Perfect. So we could do either way. You guys like just make sure, since you're talking about range, what letter should be in the middle now? Y. Good job. Yep. And then watch how they try to trick you on the exam, like putting ones that look the same but with the wrong variable in like that. Okay, so it's going to be just the same idea. Go with the Y in. And you could do the same thing here if you wanted to do a bracket instead. That's okay. Right, do the same thing. I have been seeing a lot of this stuff come up quite a bit. There's usually going to be probably 2 questions on your exam. Something about maybe a function. A function, we need to make sure you guys know it has to pass the vertical line test, and the x-coordinate cannot repeat. So if you guys had a picture that looked like this, okay, and you tried to do the vertical line test, how many times does it touch? Twice. So this would be not a function, because it touches more than 1 time. Right? That's because the x-coordinate would repeat twice. Similarly, 1-to-1 means it passes the horizontal line test. So if we had something like an absolute value, and we tried to do the horizontal line test here, this would not be 1-to-1 because it touches twice. Okay, and way through. And then 1-to-1 is a y-coordinate, can't repeat. It's kind of the total opposite of what a function is. The one that's been on a bit lately is the idea of onto. Onto means all the y-coordinates are used. So just some key vocab that we need to make sure you guys know. So in this problem, example 3 I think is kind of tricky. Which equation does not represent a function? How can we tell? Yeah, go ahead, graph it with a calculator, yep. And I'll show you a way you could tell just by looking at this. You can tell which one's not going to be a function. We try y equals 4. I like what you guys were thinking though. Definitely calculators can influence you this. Okay. So we tried y equals 4 and try the vertical line test. Yeah, this is fine. It only touches 1 time. This one's good. So this one we have x squared minus 4. This should be a parabola because of that x squared. Is it minus 4? Yep. Does this one work? Yeah, good. Passes that vertical line test. That's good. Right, and then okay, the next one, x minus 4 should just be a straight line. There we go. Hopefully this one passes. Great. Anybody seeing some kind of issue so far with the next one?
You have to like decide to y.
Yeah, you have to get y alone. But if you guys try to get y by itself, well, you have to minus x squared. How do you get rid of something squared? Square root it, right? So if you took the square root here, how many options would you have? Two, the plus and the minus. What this is, guys, this equation, if you do the positive and the negative part, it looks like this. What kind of shape is this? It's a circle. Remember when you guys had an x squared plus a y squared? This is an equation of a circle. Okay, would this pass the vertical line test? No. Okay, you can look right away. If you see something where the x, actually I would say even more the y is squared. If the y is squared, it's not a function. They like to now relate equations of
Please excuse the interruption. If Justin Roberts is in the building, report to the main office at this time. Justin Roberts.
So which diagram here, this is one I see quite a bit. I think they had one in the last exam like this. Represents a relation that is both one-to-one and onto. So they make, so you guys need to know what those words really mean. One-to-one. Does anybody want to tell us what that means?
No y repeats.
Good. Good. No y repeats. Good. So no y repeats. Okay. And onto
Means they're all used.
perfect. All y used. Super. Okay. So in these, we have A, B's, and C's. What these represent is the first one is like your x, and the second one's like the y. So if you guys go through, see if you can figure out which one has no y's that would repeat, but all of them are used. Yeah, you guys are all agreed so far? That's good? Because all of them are used, and we don't have any two arrows going. With this one, the y would repeat, so it can't be that. Same thing, this one's not used, these two aren't used, and that one repeats. So it has to be choice 4. Easy for you guys? Perfect. I see those come up. That's been among the last two. Alright. So inverse, maybe you'll see something. It's kind of like hit or miss. I don't see it all the time. But we've done a lot with it. If you guys have the inverse of an ordered pair, just like 3, 2, all we do is switch the spots of x and y. So they really like just flip. And the steps for the inverse is basically the same thing. If you guys are trying to find the inverse of an equation, all we do is switch the spots of x and y. So where I see a y, I'm going to write an x. And where I saw the x, I'm going to put a y in. Right? And now we're going to get y alone. So solve for y. We want to move everything over. So we should be minus 2. And then divide by 13. And that is it. So now your y is alone. So this would be the inverse, which would be choice 3. Right? And the inverse is always a reflection over that line y equals x. So if you guys graph both of these in a calculator, so if we do 13x with a minus 2, and then what's plus 2? Alright, so if this was your original, 13x plus 2, and then if we graph with the new one that you guys had, we want to put parentheses around the top, because those are together, divided by 13. And so if we graph these, it should reflect around the line y equals x. Is that the line y equals x? And, oh, there it is. I wish I had the color screen up. It's hard to see on that. So here's one of them. Here's the other one. Those two, they reflect around this green one. like perfectly mirror image, right? It's always going to work. If you have two things that are inverses, they always reflect around this line y equals x. Yeah, Ashley, what's up? Well, that, all that does is gives you the green line, so you can tell that they're reflecting around it. You don't have to. You could like look at it and tell it's fine. Alright. That's good. Okay, composition of functions, this is a big deal. You guys will like definitely 100% see this on your test for the composition. You like these? Okay. They're easy when it's a number. I think they're a little tougher when it's like an X. Yeah. So the biggest thing is they have to give you guys two different functions. Maybe an X and a G, an H and a K. Here we have an H and a G. The idea is where you start is very, very important. Do you guys remember which one to start with? G, good. Yeah, you start with what's on the right side. Or whatever's closest to like the number or the X. So this we're going to start with G. Okay. So in your G function, my G function is up here. What that means is where I see an X, I need to put in a 2. Yep. So it becomes 3 times 2 plus 1. Okay. We're going to actually solve it all up. Right, 7? Mm-hmm. Okay, good. Now 7 is not our answer. This is going to be the new X. And we're going to use the other function. So now I have to use my H function because I haven't used it yet. So in here in your H function where you see an X, now we're going to take our new value and plug it in here. So it becomes 2 times 7 minus 1, which is going to give us 13. And 13 is going to be the final answer. Okay, so this is the one we want to use. That was easy for you guys? Mm-hmm. Okay. I think it's fine for this. Alright, so here's just a little different way that you guys could see it. Okay. Using the same exact H and G, I'm going to have you guys find G of H of X, which is a little bit trickier. This?
Oh, I thought you meant the 2. Okay, because never mind.
That's a good thing. If you guys have an X here, you should get an X in the answer. You shouldn't have like a
I thought you were just flip-flopping the top.
Oh no, it's not that nice. Which one are you guys gonna start with here?
H.
H this time, good, because the H is closer with the X. You guys want to start with on the right side. So in the H function, you don't have something to plug in here. It's just H of X. So we need to figure out what is H of X. Do we know what it is? Look up above with what they tell you.
Oh, yeah, that's fine.
Yeah, good, 2x minus 1. They tell you H of X is 2x minus 1. So this, when you guys have the X, it's like one full substitution. This whole thing is the new X. Now, which one haven't you guys used yet? Good, that nice, Kayla. That G, you still have to use, right? So G is that 3x plus 1. Now make sure you are doing a substitution, right? Don't multiply. So when we take that 3x plus 1, this is your x. So we need to take this and put it in place of just the x here. So we're going to get rid of the x and put this in its spot. So it turns into something like 3. No more x. We're going to put 2x minus 1 instead, and then plus the one that was already there. This is what we want to simplify out now. So just make sure you distribute through 6x minus 3. We add 1 and then combine our like terms. 6x minus 2 is going to be our final answer. That was a little bit tougher, wasn't it? So we haven't done with an x in a while. I should put that in like a CRC. Do you have more stuff? Oh, you have circles. I forgot about those. Okay. Alright. So circles, you guys will see something come up. An equation of a circle has to have your x part squared and your y part squared. So these mean the same exact thing, except if you guys had just an x and a y, there was nothing in parentheses, all that means is the center's like 0, 0. There's like a 0 there. if you guys have something with like numbers here, we switch the numbers, so we can negate them, change the sign, and then we always have to take the square root of what's over there to get your radius. So if you guys had something like, easy like this, does anybody know what the center would be? 2, -5, awesome. You just look at these values and you switch the signs, that's it. What's your R? 3, good. You take the square root of 9. Now, I don't think you'll see something this easy. What I see all the time though, and I bet you'll get one of these, is converting into center radius form from standard form. And to do this, you guys have to use completing the square. No. Yeah. Oh my gosh, he knows it. Good job. Group your x's together, and then group the y's together. And what I mean by that is just write them like together. Nice job. You're welcome. Bye guys. X squared minus 4x. Then we'll have plus y squared minus 6y. And after this, group your x's and y's together, we're going to move all the constants to the other side. So how do you move a plus 8 over? -8. Good. Okay, perfect. Now we're ready to do the completing the square. So we just have to do this twice. Okay. So when we complete the square, okay, it's going to kind of turn into what a circle equation looks like. Right? I'm going to break down the letter, then I'm using my x, I'll have it squared. We want to take half of the middle term. So half of -4. -2, good. Now we can't just do something with this, we have to do something the other side. What did you guys have to do with that -2? Square it and add it over. Good. So -2 squared is 4, and add that 4 over. Why don't you guys see if you can come up with the second bubble? Do the same thing. What did you guys put in there? -3, good. And what did you add over? +9, awesome. So then at the end, all you have to do is add these together, and you should get 5. Okay, good. Right, so then we have x squared minus 2 minus 3 squared equals 5, and that would be your final answer. I think we've done a lot of those, kind of. This we haven't done in a while. You're writing an equation of something with a circle. I haven't seen this come up a lot when you guys are actually like using points to make a circle equation. It's usually more like completing the square stuff, but you never know. Alright. So write the equation of a circle whose diameter has endpoints. Oh boy, this is rough. Okay. And if we need to, give yourself a picture. It doesn't have to be great or really like even, you know, perfectly correct. But if you guys know a diameter goes through the center and it has endpoints of 4, -1, and then -6, 7. So that's all we know in this. When you guys make an equation of a circle, it needs to have a couple of things. I always start with this. I have the x squared plus my y squared equals r squared. And these parts are going to come from your center point of your circle. Now, in here, do we have a center point? Do we know what the center point is?
No.
No. Okay. So there's a couple things that you guys, midpoint formula and distance formula are something you probably want to be familiar with. There's other ways to, instead of using the distance formula, but midpoint will help you. If you want to figure out the middle or the center of between 2 points, we want to actually figure out what that middle point is, or the midpoint formula to figure out that center point. So when we use our midpoint formula, what we're going to take the two x coordinates and add them together. If I take 4 plus -6, what would you guys get? -2. Good. And if you divide it by 2? -1. Good. All right, and we're going to do the same thing with the y coordinate. If I take my 2 of those, add them together, -1 plus 7, 6, good, over 2 is going to give me 3. Great. So this, guys, is your center point. Okay, the center point is -1, 3. Now, once you guys know the center to go back into the equation, what do we have to do with the sign? Good, negate them, I flip them. Good, so this is gonna be a +1 and then a, perfect, good. All right, now, there's an easy way to get the r squared. Anybody remember? Yep, you got it, Lil. All you have to do, guys, is find the radius squared. You do not need to use the distance formula. If you want to, you can. There's something that is much, much easier. Right? All we're going to do is take our equation and pick one of the endpoints. So you can pick either one of these if you want to use. Anybody have a preference? 4, -1, perfect. We're just going to take the x and the y. Those are going to become the x and the y in here. So when we take our x being 4, we're going to take 4 + 1, square it, plus the y coordinate, which is -1 - 3, square it, and that's going to equal radius squared. So all we have to do is actually solve this out. So this is going to give us 5 squared, which is 25, plus this is -4 squared, which is a +16. Now if you guys add those together, what are you going to get? 41, perfect. So look at 41 is what r squared equals. So when you guys go back to your equation now, all we have to do is get rid of the r squared and put in 41. So our final equation here is right here. This is going to be your equation of the circle. Isn't that way easier than doing distance formula? Mm-hmm. Yeah, and it'll work.
Yeah, we're gonna find that.
Yeah. Teresa Lilac actually, like, she was like, well, can't you just do this? And we, like, we're like, oh my god, it's so simple. So much more simple than using distance formula. If you look at it, see how the distance formula, what it actually is like the difference of x's, and it's kind of very similar to what we had down here. Except you're not doing the square root, because we don't care what the radius is, it's r squared. So, just something you don't have to memorize. Thank you guys so much for coming. Hopefully it was helpful.